Okay. Last time we did call by value, call by reference. Okay. And before that, I explained you the concept of pointer, right? And with the help of pointer, we did the call by value and call by reference. So today again I'll revise the concept of that pointer, and then we will move ahead and we will do a little bit problem based on the pointer so that this concept will be clear to you. And then after that we can start with the structure or string, right? And we can proceed, because now after this the topic which is remaining, that is the structure, string, and union. Okay, so once we will finish, then our syllabus will get over. Okay, so let's start again with the pointers. So as last time I explained you that pointers are the special variables which can store the addresses of other variables. For example, if I have declared like int x is equal to 10, so this is my simple normal variable. Okay, it's a normal variable. Now if I declare int, what was, just wait. So what I want over here, I'll declare one pointer variable, and we will going to hold the address of this particular variable. Now, if I tell you the address of this particular variable, then you will think from where it will get the address. So remember, whenever we will declare any kind of variable, right? This is the integer kind of variable. So this will be stored somewhere in the memory, right? It will be stored somewhere in the memory. Let's say it got stored in the memory at location 400, right? This is I am giving some location number, right? It may not be the same. From my side, I am giving some location number. Let's say this particular variable got space reserved at this particular location in the memory, and to this particular location the name is given as x, and here we have stored 10. So this is the three tasks which will be done by the compiler whenever we will declare any variable, right? Based on the type of that particular variable, that much space will be allocated in the memory at some particular location, and the name will be given whatever the name or identifier variable name you have given, that name will be assigned. And if you assign the value also, then that value will be put over there, right? So this is a task which is performed by the compiler. Now what I want, that, see, whenever you will do any kind of operation, let's say if you are doing sum is equal to sum plus x, right? So whenever you will use this particular name of the variable, this 10 value will be fetched from the memory, right? Now what I want, that whether I can access the same value based on this address, right? Based on this address, because I know at which particular location that particular value is stored. For example, if I want to access you, right? If I want to meet you, I can come to your address and then I can directly meet you, right? Or another option is I can call you and then I can talk to you, right? So if I know your location, definitely I can reach to you. So if the location is known, this particular location is known, we can easily access this value, right? So how to store this location in some other variable, right? To store the addresses of any variable, we need to declare a pointer kind of variable. Now this is an integer kind of variable. So to store the addresses of the integer variable, we need to declare int a star kind of variable. Okay, int star kind of variable. So this is called as a pointer variable. Now I can say p is equal to ampersand x. So ampersand x means the address of x is stored, inside this p. Now if you try to print the value of p, you will get the address, that is 4000. Whatever the address will be there, you will be able to see, because we have stored the address of x inside this p. Now if you have any normal variable, like if you are, let's say suppose you are int y, you cannot say y is equal to ampersand x. Okay, this is not allowed. It's not allowed because x, because y is a normal integer variable, and a normal integer variable cannot hold the address of some other variable. The variable, only pointer variables can store the addresses of the other variable, because pointers are spatial variables. Okay, pointers are spatial variables which can hold the addresses of other variables, which can hold addresses of other variables, remember this. And now I told you the two operators will be involved, that is, one is star kind of operator, this is called as value at, and another is ampersand, this is called as address of operator, address of. So value at and address of operator. So let me give one example. One example already we solved, that is call by value, call by reference, which is very important problem. Okay. In that particular problem, you saw that first time we try to swap both the numbers with the help of call by value, and we saw that after passing the variables to the other function, the swap function, whatever changes we did on the in the swap function, which that were not really affected on the original parameter, that is x and y, right? Because we did call by value, and in the call by value, the duplicate values of the variables are created, and that will be sent to the former parameter. In the former parameter, whatever changes we'll be doing, that will not be reflected on the actual parameter. But in case of your call by reference, what we actually do over there is, we don't create the duplicate copies of the variables. In fact, we pass the addresses of the actual variables, right? So to accept that addresses of the actual variable in the function like swap function, we must declare a pointer kind of variable which can hold the addresses of those x and y variable. And since we got the addresses, so whatever changes we'll be doing on the addresses of those variables will be reflected on the original variable, and that was the concept of call by value and call by reference. Hence we saw that after call by reference, we could swap the values, right? So the changes were reflected after that the swap function, and we saw that the values got swapped. But in the call by value, the values were not got swapped. Okay, let's see the pointer example. So what I'll do, I'll write one small function like void main, sorry, void main. Here I am saying int x is equal to 10 star p, then y is equal to 5. Okay. Q. So I've declared two variables, x and y. X is 10, y is 5. Two pointers I've declared, that is star p and star q, right? Now what I'll do, I'll say p is equal to ampersand x, q is equal to ampersand y, right? So in p, I'll be having the address, let's say 4000 will print, in q it will print, let's say 5000. Okay, this is the address of x, this is the address of y. Okay, now I'll write printf x is equal to %d, y is equal to %d, xy. So I'll get the value of x and y. If I'll do printf %d, let's try to print the value of p and q. Okay, p is equal to, so here I am writing %u, and q is equal to percent u p q. So we know that in P and Q we'll be having the addresses of X and Y. So I am using U. U stand for unsigned integer, right? The range will be larger. Otherwise, we know the percent D is the range is it's small. So if the value is large, it won't be able to print properly. So I've used over there as percent U, which stands for unsigned integer. Okay, I'll get the addresses of X and Y, and then let's try to print let's try to print value of X equal to percent D, Y equal to percent D with the help of P and Q. So I want to print the value of X and Y with the help of addresses. I know where X is stored. See here, the diagram will be like this. This is my X 10, and let's say the address is 4000. This is my Y 5, address is 5000. Now what about P and Q? So P is a pointer which is pointing at the address location 4000. Q is a pointer which is pointing at address location 5000, right? Now if I say here star P and star Q. So I want to print the value at, this is value at operator, so I want to print the value at P. So where P is pointing at that particular location, what is the value? What is the value? That is 10, right? So that's why I'm saying X is equal to percent D. I want to print the X value with the help of the addresses. So this particular pointer, I know this pointer is holding the address of X. So what I'm saying, value at P is what and the value at Q is what. So value at Q, where Q is pointing at that particular location, what is the value? That is 5. So with the help of this particular statement, I'll get X is equal to 10 and Y is equal to 5. Here what I'll get, let's say P is equal to some address, let's say 4000, Q equal to 5000. Okay, and here I'll get X is equal to 5, Y equal to 5. Okay, now I'll write one more statement, printf X is equal to percent D, Y is equal to percent D, and here see what I'm writing, ampersand X star of ampersand Y. So first I'm determining the address of X. Okay, so address of X will be 4000. What is the value at that particular location? So automatically the 5 value will be, sorry, 10 value will be printed. In similar way, what is the address of Y and that particular location, what is the value? So the value of Y will be printed. I hope this thing is clear to all of you. If you have any doubt, please ask me. Whether this thing is clear, what I'm doing actually with the help of pointers. Now let's say suppose I want to do in this way. If I'll do X equal to, not X equal to, P is equal to P plus 2, sorry, P plus 2, and Q is equal to Q plus 2. Now I am saying printf P is equal to percent U, Q is equal to percent U. Why percent U? Because the addresses will be a big number, right? So I want unsigned integer so that can be accumulated, that can be printed properly. And here I am saying P and Q. I want to print the value of P and Q. So what will happen? What will happen? Depending on the how much byte is allocated, right, on your particular operating system. So for example, if for integer it's taking 4 byte, okay, so it will increment the address by 4. So if earlier it was 4000, now plus 4 it will become 4004. But if it will take 2 bytes, okay, on turbo it takes 2 bytes. So if it's taking 2 bytes, then earlier it was 4000 plus 2, right? So it will become 4002. 4002. Okay, the address location will be like this. So always the pointer arithmetic is possible. Okay, pointer arithmetic is possible, but it will depends on the data type, right? Data type. So whatever is the size of that particular data type, depending on that, it will be incremented. So even if we will increment by one, right? The I mean, for example, so here, see what will happen. What I've done over here, if you are doing plus two, this will not be 4002. What will happen? Suppose we are doing p is equal to p plus 2, right? So p is equal to p plus, now 2 we are incrementing, right? So what is the data size? Data type is what? It's of 2 bytes. Let's say I'm considering, so 2 into 2. So whatever is there, right, it will become that particular site. So earlier it was 4000, so it will become 4004. So depending on the data type, if you'll do only p plus 1, p is equal to p plus 1. So let's say p plus 1 into integer size, if I am considering only 2 byte, right? So this will become 4002. So depending on the data type, it will go into increment. So this is what a pointer arithmetic is possible. Okay, pointer arithmetic is possible. Even the addition, subtractions are possible, but depending on the data type. So whatever is the data type, depending on that much size will be incremented. So I'll do what? I'll quickly demonstrate this particular example on online compiler so that this thing will be clear to you. Okay, I'm writing int x is equal to 10, y is equal to 5, star p star q. I'm saying here comma should be there. I'm saying p is equal to ampersand x, right? And q is equal to ampersand y. So I have stored the addresses of x and y, and this is possible because p and q are the pointers. Now what? Printf something x is equal to %d, y is equal to %d, comma y. So basically we are printing the values of x and y. Then I am saying printf let's print the value of p and q. So p is equal to, I'm saying %u, and q is equal to %u, p comma q, printf. Then let's print the values of x and y based on the pointer. Okay, based on the pointer. So with the help of pointer, let's try to print the values of x and y. X is equal to %d, y is equal to %e. Why I am writing %d? Because I know the values of x and y are like 10 and 5, so it will come with the help of %d, right? I'll say star p star q. Why star p star q? Because I want the value at p and value at q, right? So wherever p is pointing, what is the value at that particular location, and wherever q is pointing, what is the value at that particular location, right? Now let's try to print p and q in some other way. So x is equal to %d, y is equal to %d, and I'm saying here star of ampersand x, then star of ampersand y. Okay, to show you, let me write one more line. Let's copy this, and here let's first try to print the addresses of x and y. So I want to print the addresses of x and y. I'll write address of y and then address of x, So to print the addresses, I write %u and percent u, okay, in place of %d. So it's like first line I'm printing x and y value, and in the second line I'm printing the addresses of x and y. Then the third line, with the help of p and I mean the values of p and q I'm printing, which obviously the second line and the third line will have the same output. In the fourth line I'm saying I'm printing the values of x and y based on the pointer, okay. And the fifth line I'm printing the values of x and y with the help of some notation, like first I'm determining the address of x and address of y, then I'm printing with the help of pointer, right? So what is the value at that particular location? Then let's do some arithmetic. I'm saying p is equal to p plus 2, right? And here by this particular statement, we know that what will be the value of p and q, and then we can easily verify q is equal to 2 plus 2. Let's print the values of p and q again. Printf p is equal to %u, q is equal to %u, p, q. Okay, let's run this. So if you see here, the first line is this one, right? And it's giving me x is equal to 10, y is equal to 5. That's okay, that's very common line. Then the next line, I am trying to print the values, the addresses of x and y. So if you see, the address of x is this one, 21134928848, okay. And address of this one is 21134928852. If we see here, then in the next line, since what I did, p is equal to ampersand x and q is equal to ampersand y, right? So obviously the p will have the address of x and q will have the address of y. So if you see in the next line, the values is same, right? The values is same. X is equal to, and sorry, p and q and x and y, the addresses of x and y are same. For your reference, I'll print in some other way. For example, I'll write here address of x, and then here address of y. Address of y. Now it will be address of x, address of y. Okay, then if you see the next one, that is this one. So with the help of this pointer, we are determining the x value and y value. And then even with the next statement also, ampersand x and then star, we are determining the x and y value. And if you see in the next statement here, we got the value of p and q and some incremental value is there. So on what basis the 60 value came? I told you that if we will do the arithmetic here, plus 2. So here for integer, it is storing in 4 bytes. Okay. So for one integer, it's taking 4 bytes. So the answer will be like this: p plus 2 into 4. Okay. So p plus 2 into 4, which is nothing but, if you see here, it's 5 2 plus 8, right? 2 into 4, 8. So that will become 60. Clear? So the pointer arithmetic is possible. Only thing, the whatever is the size of the data type, I mean that the multiple of that will be no, that will be incremented or decremented. So you need to always calculate in that way. For example, if you are doing plus 2, so actually with plus 2 will not happen, right? It will do what, 2 into 4, whatever is the data size of that particular variable on that particular operating system. Now here it's storing with the help of 4 bytes, right? So if it's taking 4 bytes for one integer, then for two integer it will take 8 bytes, and that's why the incremented value is what, with 8. So whether this entire concept is clear to all of you, or if you have any doubt, please ask me. Yes, all of you? No doubt? Okay. So we can move ahead. Yeah, okay, no issue. We can move ahead, and we saw that every function can return one single value at the end, right? A function can return one value, but I'm telling you that a function can return more than one values, and this is possible. Okay, this is possible, but we know that with the help of return statement, only one value we can return. Okay, with the help of return statement, only one value is possible to return. So for example, if I'm saying int add function is there, right? Int add function is there. It's taking two parameter, int x, int y. So here, if I want to return x plus y, so I can return only one value, and from here the execution will go to the from the to the part where from where the function we have called the function, right? Now, what if I want x into y also to be returned from this particular function, right? Now, whether this is possible, we can return only one value, and which is we are in one value we are returning, that is x and x plus y, but we also want to return x into y. Then how to do this particular task? So we can return n number of values, but we need to declare with the help of pointer, and we know that if as an address we will pass any particular parameter, then whatever changes we will do inside the other function, that will be reflected. So if we will pass by address, then definitely we can return n number of values. So let's try to see one simple program to give you the example of that. What we can do, we can take let's say circle. Okay, circle, area and perimeter, that is a good example. Area and perimeter. So let's say uh, we we have to write one function. Let's say the function name will be area underscore peri, and the job of this particular function is to return two values, that is one is area of the circle and second is the perimeter of the circle. Okay, area of the circle, perimeter of the circle. Okay, before this, let's do the same problem which I explained above. Like we'll pass the two numbers x and y, and from the other function we will return two values, that is x plus y, and another value is x into y. Okay, let's do this one. So here I'm writing. It's best I'll write directly compiler. Okay. So should I delete this program, or all of you want this? Obviously the recording will be there, so you can see anytime. I'll just copy and paste over there if it's possible. So entire thing is not coming there. Anyways, I think last part didn't came properly. Remove this one. Oh. So here we will write function which will going to return an integer value, obviously add and product. Let's say add product. It will take two types of parameter, int and int another parameter, and let's say it will take one more parameter as int star type. So one parameter I'll pass as int star type, and here I will going to return the product. I'll take int x comma y, int f, enter the two numbers, scanf, ampersand x, ampersand y. two numbers we got. Okay. We'll declare one more parameter, that is product, and I'll say what here. Let me declare one more variable, that is add, and here I'll say add is equal to, or let's say sum declare. I'll declare some variable. I'll say sum is equal to, I'll call that function add product. Two parameters I need to pass, x and y, and one more parameter I'll pass address of product. Okay, address of product, because here whatever changes I'll do, that will be reflected, and that particular location I'll be storing the product of both the numbers. So after this particular call, once the values will be returned, I'll try to print. I'll say sum equal to %d, product equal to %d, sum product. Okay. Now we'll do what? Here we'll write the definition of the function. So let's say int add prod, where we'll say int x, int y, and int star. Int star, let's declare p. Okay. We'll do what? Obviously, one we can write in this way, return x plus y. So with the help of return statement, a function can return one value, but we also want before this particular return, because after this the statement will not be executed. Okay, if you write anything after this return, so it will never going to reach that particular statement. So that statement will not be reachable. Whatever you want to do, that you're supposed to do before return only. I'll write what? Star p equal to x into y. Okay, so I'm storing the product at star p is nothing but it's pointing to the product location, because address of product is passed over here. So this p is the pointer which is pointing to the product, and in the product I am storing the multiplication of both the numbers. So it's like, with the help of this kind of pointer, we can return the multiple values, and obviously with the return statement we can always return one value. So let's try to execute this. Semicolon is left, where it is, this one here, this. Enter the two numbers, 10, 5. Okay. 10, 5. Yeah. So if you see, the sum is what? 15, and the product is what? 50. Okay, 10 into 5, 50. So both the values we got returned from this particular function. Whether all of you understood this particular program? What I did in this program, I returned two values from one function. Okay, understood all of you?
Yes, sir.
Yeah. So on the similar note, uh, we can find out the area and the perimeter of the circle, and both we can return from other function. Okay, both we can return from other functions. So one parameter you can declare as a pointer, and that you can return the perimeter. Let's say perimeter formula is 2 pi r, and the circle formula is pi r square. And with the help of return statement, you can just return pi into r into r. So like area you are returning with the return statement, and with the help of pointer, let's say star p equal to 2 into pi into r. So you are returning a perimeter. And on the similar note, in the same way, you can do what? You can do the area perimeter program. So do you want me to write that particular program, or should we move ahead? will you be able to write that one, area perimeter? So it's like I want from one function I want to return two values. One is the area of the circle and second is the perimeter of the circle from the one program only. Okay, now let's see, let's try to pass, let's try to pass the array from one particular function to the other function, and let's see what will happen in that case, and how we can pass the elements as well as the entire array to the other function, and how we can do the operation. Okay. So what I want, for example, suppose I am having one array. Let's say I am having one array of 5 elements. 1, 2, 3, 4, 5. This entire array I want to pass to one function, let's say sum function, and this sum function must return the sum of all the numbers. Okay, sum of all the numbers. So it will return, and then we will going to print that. Now there are two ways. Okay? There are two ways. So from this particular array, we can pick one by one element and we can pass to the sum function. And the job of the sum function is to store the values, right? So that is the one function. Second function is what? A second way is what? We can pass the entire array to this particular function, and then we can directly process it. Or let's say I'm passing one array, and then the second function will going to print the square of all the numbers one by one, right? So let's write this one by two different ways. I'll be writing this. So just check it. Void main. Let's say I'm having one integer a of 5 elements, 1, 2, 3, 4. Okay, let me write on the online compiler only so that you will understand. Okay, so let's pass the element by element of the array, and then we'll do. Here I'm declaring int a 5, and let's say suppose I'm having the number, I'm initializing also 1, 2, 3, 4, 5. Okay, I'll declare one more variable, that is I. So what I'll do, I'll say printf array elements are. Okay, and I'll apply one for loop for. Here I write I equal to 0, I less than 5, because 5 elements are there, I plus plus, and I'm printing printf. So I'm just printing the array elements. %b one space a of I. So I have printed. Now what? Now I'll be writing one square function. Okay, one square function, and job of that square function to square the to square the every element of this particular array. So I'll do what? For I equal to 0, I less than 5, I plus plus, and here I'll say square a of I, square a of I. So it's like I'm calling that square function, and I'm running the loop. So first time this square function will get the a of 0 value, then the second time it will get a of 1 value, a of 2, a of 3, a of 4, right? And one by one this particular square function will do the square of the elements, each and every element. So my task will be done. Now here I'll just define it. So my this function will not going to return anything. So void square, and in this square only I'll going to print. So one by one element it will be sending. So in fact it will be sending the integer number only, right? Because if you see here in the array what we are having the elements 1 2 3, all these integer values are there. So one by one element it will send to this particular function. Here I must have one n value, right, integer value, to hold that number. And simply here what I'll do, printf %d n into n into n. So I'll just square that number and I'll print, right? So one element it will send, I'll just n into n I'll print. Then the second number it will send, I'll print n into n, right? Let's run this. Okay, yeah, one more thing, since I'm writing the square function after this main, so I must write the prototype of that one. So here the prototype of the function will be what? Void square and int, right? So this will be my prototype, because the function is not returning anything, so it's a void. Name of the function is square, and type of parameter which is taking, that is an integer. Let's run this. Yeah, so it came. Let's print 1/n after this. Okay, yeah. So printf, and let's say printf square of array elements are. Okay, let's run it again. So if you see here, array elements are this one, and square of the array elements are 1 4 9 16 and 25. So this is the one way I can pass one by one element of the array to the other function, and then I can process it. Okay. And the second way could be directly pass the entire array to this particular function, and then we can process it. So whether this method is clear to all of you? I have done what I've declared the array, and I'm passing one by one element to this function, and then I'm printing the square of each and every element. So I hope this is clear to all of you. Okay, let's see the another method. Here what I'll do, I'll directly send the entire array. Okay, I'll send the entire array. So let me show you how I'll do. So till here everything same. I printed all the array elements, and then I printed square of the elements are that statement also. And then I'll call the square function, and I want to pass that array. So I'll pass a. A is what? A is not a variable. Sorry, A is not an integer variable. It's simple integer variable. It's what? Array. And it's taking what? 5 values. So I have passed A. A is what? A is the name of that particular array. So let's understand this concept. Once I have declared this int A 5 equal to 1, 2, 3, 4, 5, right? And what I'm saying over here, square, and I'm passing A. So I'm passing A means what? A is nothing but it's a pointer only. Okay, A is a pointer because this is the name of the array. Okay, it's the name of the array. Name of the array. Name of the array. And it's an identifier itself. Okay, it is a pointer which is pointing to the first element address. Okay, the name of the array, remember, name of the array always points to the address of the first element, to the address of the first element. Okay. So let's say the what compiler will going to do, compiler will going to allocate the space for this entire array. So in my machine, if integer is taking 4 bytes, so here we are having 1 2 3 4 5, right? 5 into 4, so 20 bytes of memory will be allocated. So it will be like this, 4 4, right? 4, this is 4 and one more 4, right? 4 bytes. This will be a of 0, a of 1, a of 2, a of 3, a of 4. A itself will point to the address of the first location. Let's say this is 400, this will be 4004, this will be 4008, understood? 4012, 4016. So the addresses will be like this. And the name of the array itself will going to point to the first location. Okay. So here, if I ask you what I am doing, I am passing a to this particular square function. So whether this is a call by value or call by reference. This function call is a call by value or call by reference. Yes, anybody? Okay, one thing is clear. So this will be called by reference. It's not called by value because I am passing the address. Okay, this is a pointer. Now to hold this entire array, I must have either pointer variable or I must have the array declaration over here, right? So that it can hold the entire values. So what I can do, I can have in this way. Let's say a of 5, right? And then that array will come over here, and then in this particular function I can write int I for I equal to 0, I less than 5, I plus plus, printf %d space a of I into a of I. So it's like entire array I am having, and then what I am doing, I am printing a of I into a of I. First time 0th element square will be printed, second time first element square, then the second element, third element, like this. So this is how I can write. This is by the another way. Where is the mistake? Printf printf okay. Yeah, so this it's not taking, right? I've declared there int a array, so it's not taking. Why? Because what is my prototype? Prototype I have not written properly. This is the previous program prototype. And if you see here, this is the address I am passing, so it must accept what pointer kind of variable. So here, this is what a pointer variable, or since I have declared there as a integer, right, array type, so I must declare in this way, because this is what my signature of the function is, or void return type, name of the function was square, and it's taking what, int a array of 5, right? So I've declared here the syntax in this way, that my parameter is what, array type. Let me run this here. So if you see here, I have changed this parameter. I changed this prototype, and then 1 2 3 4 the array elements are there, and I pass the entire array. this entire array A to this particular function, and then I manipulated the elements. Okay, so this is with the help of array name. I can pass the entire array to the other function, and with the help of that particular array name, I can access it. Okay, by the way, whenever we write in this way, right, whenever we write in this way, A of I, what actually we mean? See, for example, let's say this is my array A of 0. A of 0 is what? 1, 2, 3, 4, 5. This is A of 1. This is A of 2. This is A of 3. This is A of 4. So we know that the name of the array itself is a pointer to the first location. Okay, pointer to the first. Let's say the location is 4000. So A will have the value 4000. A will have the value 4000. Now when I'm writing A of 1, when I'm writing A of 1, this is nothing but star of A plus 1. Okay, star of A plus 1. It will be, the compiler will going to convert this particular notation in this way. Star of A plus 1. So this star of A plus 1 means what? Star of, that is the value at A is what? 4000, right? This 1 into the size of the integer over here is 4, right? So value at 4004 location will be what? So 400 location will be what? This is 2. Okay, this is 4004. So 2 value I will get. So whenever we write in this way, the compiler is going to convert in this particular way. Even if we'll write this A of 0 will get converted to what? It will get converted to value at A plus 0. Okay, so 0 into 4, 0. So value at A. So value at 4000 is what? Right? So that is the first element, that is 1. In this way, it will going to convert it. So if we write A of I or I of A, both is correct. Okay. One day I ask you this particular question, if we're going to print A of I or I of A, both is correct, because ultimately the conversion will be star of A plus I. Or if you write I of A, this will be I plus A. So both the values will be generated same, whether you are writing A plus I value at or value at I plus A, both the values will be same. Okay, now the time is up. Anyway, we learned today a very good concept. I hope all of you will be able to revise this thing by seeing the videos. So I'll just stop the recording, and if you have any doubt, you can ask me tomorrow.